Okay, so at the end of this video 2, for 7.4a here, I described how you can use x plus 5 and x plus 1, um, multiply it with each of the three fraction terms, and get rid of the denominators. And at this point, they want everything simplified on the left and simplified on the right. And just an observation is that I'd have x squared plus x, and then the plus 4x left over from the second fraction. X plus 4x should add up to 5x. So I should be able to add these terms together and get 5x. And that would be the simplified left-hand side. And the right-hand side is 2x plus 10. Okay. Click submit. It's going to take its time. Okay. So what should happen from here is basically we're trying to solve for x, and we have to recognize when we start doing things to both sides of the equation what type of equation we have. And what we're gonna I think realize is that this is not a linear equation but a quadratic. Okay, so here it is right here. X squared plus 5x equals 2x plus 10. I see that x squared term, and I realize that there's nothing on the right-hand side that is identical that's going to cancel it. So unlike the first two problems that we did, um, or however many we've done already, 2 or 3, uh, the x squared is going to stick around, and so we have to solve this not like chapter 2, but like chapter 6, section 6.4, when you solve the equations by setting them equal to 0 and factoring. So let me just kind of talk you through. If I were to subtract 2x from both sides, I would be subtracting 2x over here as well, and I'd have a 3x. I subtract 10 from both sides, I'm going to have a minus 10 over on the left. So with the x squared plus 3x minus 10, you're going to end up with factors of x plus 5 and x minus 2. So your solutions are going to end up being minus 5 and 2. Okay, so I'm kind of skipping a little bit of steps here, but you would have to just think about what you did in section 6.4 in terms of setting each factor equal to 0 and solving. Those would be your solutions. But look back at the restrictions. Negative 5 and negative 1 were originally our restrictions based on what we had done in part 1 of this problem. So you'd want to have that written down next to you to compare it to these answers, and you'd say, oh, minus 5 was a restriction, it can't be a solution. So our only answer would be 2 for this particular problem. Okay, so hopefully what I said makes sense. I mean, you should kind of remember how you would solve something like this by getting it set equal to 0 and factoring, like in section 6.4. You'd get negative 5 and 2, but we got to cancel out the negative 5 as a solution. Okay, here's another example. They want us to find the restrictions. The two denominators that we've got, only one of them has an x. If we were to set this denominator equal to 0 and solve, we'd get a negative 9 for the answer, so that would be the restriction based on the fact that we don't want to divide by 0. And in this example, identifying the lowest common denominator, I've got 10 here, which have basic factors of 2 and 5. X plus 9, because the plus sign attaches the x and the 9, it's one factor. I can't look at the pieces of 9, it's just a single factor. So It doesn't make much of a difference either way, but these two factors are unrelated. So 10 times x plus 9 is going to be the lowest common denominator. And we can write that in there. 10 times x plus 9. And then if I multiply that on both sides, it's a little more basic than some of the questions we've been doing, because all we'd have to do is on the left-hand side, we'd multiply it, the x plus 9s would cancel, you'd be left with a 10, and the 10 would distribute in with the x minus 3 on top. So we'd get 10x minus 30. On the right-hand side, if I multiply this thing in purple, the 10s would cancel, x plus 9 would multiply with the minus 5. So I'd end up with a minus 5x minus 45. Those are the left and right hand sides. And then they just say, well, what's the answer? This problem is linear, okay, like the first ones we did, where you just try to get x by itself. And we could add 5x to both sides. We'd get 15x over here. I could add 30 to both sides. I'd get a minus 15 over here. Divide both sides by 15. I should end up with a minus 1 as a solution for that. So those are basic algebra steps trying to get x by itself. You should get negative 1. Check back. Based on your restrictions, you found initially that minus 9 was going to be the only problem. We got minus 1, so we're okay. Here's another one that's fairly basic. How many of the denominators have x on the bottom? None of them, so we can say no restrictions at all. That's always nice. So we don't have to worry about any problems with the answer we get. Lowest common denominator. With regular numbers, you can just say, you know, what's the most of each type of factor? This is going to have two 2's in it. Even more easy than that, it's clearly the number that they all divide into. Okay, so 4 is the lowest common denominator. In tutor mode, we'll do the steps. If I multiply this by 4 on the top, I'd end up with well, that's what they want to know first. Lowest common multiple is 4. And then if I multiply it on the top, I'm going to end up with 2x. After the 4 and the 2 reduce, I'll have a 2 left on top. On the right-hand side, the 4's will reduce completely in the first sweep through, so I'll have a negative x. And then 4 multiplied with negative 3 over 2 should give us a minus 6. So when we solve this guy, we've just got to add x to both sides, add a 1x. That will become a 3x. And I divide both sides by 3. I should get a minus 2. So I don't even need to check restrictions because there were none. I can just say, alright, here's my answer. You can check it to see if you're right, but not to worry about restrictions. Okay, there's not much time left on this video, so I'm going to leave this one to be, this type of one to be done by you, but it's like what we've just been doing. I'd say of all the problems we did out, you know, something like this, or something like the one that was quadratic, that one of the solutions disappeared. Those are the kind of the trickiest questions from this section. Let me know if you have any trouble with this. I know that traditionally there have been questions about this section, you know, from previous classes. There's, you know, a lot of steps involved with problems like this especially. So definitely let me know how I can help, and I'm more than willing to meet with any of you and help you out and do more examples if you need them. Alright, good luck.